This is Sai Gautam. Today, me and my teammate Venkat, we are going to present our data center project, which is about collaborative project management system with intelligent task distribution and scheduling. So let us look at what's the project overview and some of the key goals we accomplished here. So we developed a collaborative project management system to automate and optimize task allocation for improved team productivity and communication. Some of the key goals we accomplished here are efficient task allocation based on workload, skill set, and availability, and real-time collaboration to keep team members informed of changes and progress, and automated notifications and reminders to help team members stay on track and maintain productivity. Scalable architecture to ensure smooth performance. Here are some of the software and hardware components we used in our project. So for API interfaces, we used Fast API, and as database, we used PostgreSQL. For messaging services, we used Kafka. Redis is used for caching, and Zookeeper is used for distributed log manager. Then Docker engine is used to create containers. We did all the deployment and testing and debugging on our local host. So now let us look at the architectural diagram, like which shows the interaction between these components, how these components interact and how they contribute to the task management. So looking at the interaction between these components, how do these components interact and what do they do by interacting? So let us see what happens here. So our system uses a fast API based REST API as the main interface for creating, assigning, and updating tasks. So the API interacts with the PostgreSQL database to securely store and retrieve task and user data. Then the task scheduler manages a task allocation using Zookeeper to ensure efficient, conflict-free assignments. Redis is used for fast data retrieval, optimizing task distribution and decision making. Real-time updates are sent via Kafka messaging services, keeping team members instantly informed of new or updated tasks. Zookeeper ensures consistency and prevents errors during simultaneous task assignments, creating an efficient, reliable, and responsive project management system. Docker orchestrates and scales all these components, ensuring availability and efficient resource management. Now let us look at the debugging and testing methods we used here. So as part of debugging techniques, we did unit testing to verify component functionality, integration testing to ensure smooth data flow between components, distributed debugging to analyze logs to fix task duplication issues, real-time issue resolution to monitor logs for quick error fixes. Testing approaches involve A/B testing to test fast API endpoints with curl commands, load testing with to test Kafka scalability under heavy loads, user testing to simulate real-world scenarios to validate performance, and system monitoring to monitor performance and resource usage via Docker. Next, the working system will be explained by my teammate Venkat.
Okay, moving on to the execution. So this is our user interface where all the endpoints are defined. And if you look at the users right now, there is only one user, and whose state is unavailable because his maximum capacity is one, and he's already assigned a task. So let's see the task. So he's assigned with a particular task. Let's create a new task, and then the task number is 3 with the priority as 3. So if you look at the message here, it is saying that the status is pending because we are using real-time Kafka streaming, and the message is delivered by the Kafka producer, and it is to be consumed by the consumer. And if we look at the task status one more time, so here the status is still pending because the user is already assigned to a task, and that's the reason his status is pending. Let's mark the user to the task 2 as completed. So if we try to delete the task 2, here it says that the task is not found because the task is not available. Let's then the task number is 7. So because the user is already assigned and it is already in the progress, it's not completed. So it is not deleting the task. So let's mark the task as completed. And here it is marked as completed. So if we look at the users again, so the task number 3 is assigned. Task number 3 is assigned because it's intelligently looking for the queue, who is in the queue, and then it automatically assigns them back to the users who are already available. If we look at the messaging system, so this is the real-time updates that delivered by the Kafka. Initially, the task status is not is completed. So then the user become available. When the user become available, then the users who are in the pending state will be assigned to the user. So user pending task will be assigned, and then user becomes unavailable. So this is all about the execution. And moving on to the other things like the performance handling and the limitations. So the project can scale up to the hundreds of users via Docker, and the real-time updates are managed using Kafka as the real-time streaming, and the database load is reduced by using the Redis caching. So these are some of the limitations of our project. The project can slow down under heavy caching because real-time caching is used using the Redis and then Kafka. So this might encourage some load on the Redis, and Kafka latency also occur with the large queues, which can delay the notifications and then assigning the task to the users. And database overload might also occur using the Postgres loads. So yeah, that's all about our execution. Thank you.